Here it is again. It's going even better. I took it all apart, cleaned up everything, and here's the air gap. Between the rotor magnets and the coils, and there's ferrite core in there. It's only about 5 millimeters wide rod, and it's about, I don't know, 25 millimeters long. I'm not sure, but that's how long it is, from there to there. And they're bifilar coils. So what I've done is I've got one half of the bifilar, the other half of the bifilar over here, and then I connected them together so it makes it like a thick wire, thicker wire, so you make more amps. So the amperage coming out of here is 420 milliamps. And if I take off, it's 380 milliamps with just a single wire. But when you put the bifilers together, you parallel the bifilers, you get 420 milliamps. This is shorting it through an ammeter right now. Now here's something interesting. I'm getting 90 milliamps. Draw. This is to draw while the coils are shorted out. All 8, no, there's only 6 coils now. What I did is I have 3 coils here in series, 3 coils in here in series, and then here's 1 coil all by itself, and here's the lead for another coil all by itself. This is because I want to get 15 volts so I can run an inverter with this. And that last video I calculated about 5 volts per coil, and right now I have them all hooked up in series, 6 coils in series right now. And I'm making for voltage, I believe 31 volts. Let's look at the voltage. This is an AC. Now here's the voltage I'm making. So what I need to do next is just use 3 of those coils, not 6. And I should have enough to run my little inverter, my stat power inverter. Let's go back to amperage here. Okay, here's the amperage. Now, this is very interesting. I don't know why, but let's say I'm running at 3. Running 3. Here's the draw, 120 volts and 70 milliamps. It was actually 60 milliamps a little while ago. Let's put it in milliamp setting. Ooh. One moment. Okay, I have it in milliamps. And we have 91, 92 milliamps instead of 70. So that's the draw going into it from the grid. Now, I wanted to show you was, let's say we hook this up again. We're hooking up the output. Here's a single wire of the bifilers, and we're making 380 milliamps. I hook up the bifilers together in parallel, and now we have 420 milliamps. Okay. Now we have 120 with them in parallel over here. The alternator here is making 420 milliamps and 38 volts, 31 volts, and this is the draw now. Remember, it was 91. That was with the generator running free, not shorted out into the ammeter. 91 was unloaded. This is with it shorted. Okay, now what? See if it'll do it. When I take off, when I go with a single wire, so I'm making 380 milliamps, the draw goes up. You would think the draw would go down because there's only one of the bifilers going through the ammeter, shorted out through the ammeter now. Logically, it would take more draw, but it's taking, logically it would take less draw, because it doesn't have as big a load going on. So let's hook up the bigger load of these two wires in parallel now. So it's a thicker wire, more or less, and we're making 420 milliamps. And look, the draw went down to 120. I'm going to take off there. Now I took it off. Just a single wire going through that ammeter at 38. And look, it goes up 29 milliamps. No, 19 milliamps. It goes up 19 milliamps. Here's with both wires hooked up. Isn't that interesting? Okay, well, we're almost getting there. I gotta go, so I will talk to you guys later. Thanks for watching.